Okay, just a few updates. I've had a few people ask, when's the electronics course starting? I'm working on it. It's just a lot getting all the training material written out. I don't want to say it's mind-boggling the amount of stuff I'm trying to get together, but it's a lot that I'm trying to put together. I'm trying to make this going to be a really good course. So I'm working on it. One thing I do want to get, because I think I'm going to recommend it as a product for people to buy if you want to do the hands-on portion of the course. We talked about equipment, signal generators, there's oscilloscopes, multimeters, all kinds of stuff. There's a modern device out there. Feel free to look it up. I'm going to try and do some searching around. I think I found a company I might be able to get them for a fairly decent price here in the U.S. Maybe I can work out some kind of deal with them where, if they buy, because that's another thing I'm working on. I think I'm just going to default to, I'm going to have to get a website. I've looked at a lot of companies that have free training education platforms you can use. Honestly, I think for what I want to do, most everyone I've looked at is just too complicated. I don't want any of this. The course itself is going to be complicated enough for people. I don't want a complicated user interface. I just need somewhere for people to go download course material, take some multiple choice tests where they can pass it and go on to the next one and whatnot. And just when I need to post some information and have a chat forum. That's it. Don't need any flashy anything. I'm a boxy square person. Test equipment. I like big industrial looking stuff. I've gotten to the point where I try to use computers as little as possible. I used to love using computers, and I absolutely hate them now because I've just learned that people do nothing but honestly waste their entire life online nowadays. So I try to stay offline whenever possible. But like I say, as far as test equipment goes, there's a product, you can look it up. It's called Red Pitaya. So it's R-E-D and then P-I-T-A-Y-A. Red Pitaya. I think that's how it's spelled. Shoot, I almost need to look it up. Let me grab my tablet while I'm jabbering here. But it's you can use the little thing for anything. It's a microprocessor, basically like a microprocessor development board, but it's an oscilloscope, a spectrum analyzer, now actually a 2-channel oscilloscope, 2-channel spectrum analyzer, 2-channel signal generator. It does all kind, and you can also get accessories for it like LCR meters, very high quality and accurate. You can do some amazing measurements with that thing. Logic analyzer, and its user, because it's an open source platform, you can basically make anything for it. You can design your own stuff to use to interface with this thing. And there's all kinds of, you can make software defined radios with these things. People have used them to make transceivers. So, a receiver transmitter. It's just amazing what you can do. So let me see here. Red Pitaya. Yeah, Red Pitaya. So we can get it to focus on the website. redpitaya.com from STEM Lab. But move the camera down here actually. But yeah, that's the little box right there, and there's all kinds of. It's just amazing. Now, there's no display. It's just a little module. But you can interface this thing with your cell phone. You can interface it with a tablet, with a computer, with everything. And I think that's for a lot of people nowadays. A lot of people have tablets nowadays. A lot of people have computers. But I think the tablet's actually kind of nice. The screen's fairly good size. So you don't need a gigantic computer sitting on your bench. You can just take your tablet, put it in a little thing like this, and stand it up. Bam, there's the display for it. But I know it's kind of hard, it's kind of blinding the camera, but they're actually flashing by all the little optional modules you can get for this thing. Now this is actually because this is, I guess, made in England. Well, it's probably made in China. Everything's made there, but it's actually a European country or company. But you can get these in the U.S. Like I say, but I want to do a little bit of research on that. I think this might be a good solution. a one-box solution for a lot of the... Actually, it's going to be more than you're going to need. You're not honestly going to need a spectrum analyzer for this course, but honestly, if you get one of these things, that would actually be... I could do like a little add-on little section of courses on using spectrum analyzers and whatnot. But yeah, like I say, it's FPGA CPU based, it's open source, it just does so much. And it's relatively, if you consider how much you'd have to pay for a signal generator, for an oscilloscope, for a spectrum analyzer. And like I say, if you get the other options, you can get different kits. If you get the ultimate kit, honestly, you're looking at like $1,000. It's not cheap for the all-out kit, but that has the LCR module with it, which is another little box. The logic analyzer comes with all the probes, the cables, everything. Basically, all you need then is something to interface with it. Like I say, like a tablet, a computer, even your cell phone. Another thing is it can be remotely operated. So, and I want to get one of these. I think I'm probably going to get the ultimate kit, which will have every measurement tool that you can get with it. But this might actually be good, so if people are having trouble doing something, they'll be able to link their Red Pataya online, so either another user or even me or somebody else can view what they're seeing on their Red Pataya, kind of like sharing computers and whatnot, but you just be sharing your Red Pataya. But and then people can say, oh, well, that's because you have your volts per division aren't set correctly, and they can make changes to the parameters you've set on it. But yeah, I'm going to get one. I've been looking at them, been looking around at test instruments, and honestly, for the money, this little guy is going to be hard to beat. It's a little box. Actually, it's just a board. You can get if you get the kits, they come in a metal box like that. You can get clear cases. You can get clear cases with slots because, like a lot of development boards, it has rows of header sockets on it. So if you're using other things with it, you can just stack the boards on top of each other to interface them together. But yeah, so I really think that's going to be my go-to recommendation, probably minimum amount of money for the maximum amount of equipment, I guess is the way you could look at that. So, but like I say, that's what I've been dealing with, stuff like that. Because I was looking at scopes and as I launched the camera across the room, get back in the holder here. Sorry about that. Didn't have it clamped in properly. But yeah, that and trying to get my bench reorganized some here. So equipment. So of course it's coming. I'm hoping within a few weeks I can start doing some videos. I've got a good bit of the DC portion written out. It's just a matter of I really need to get my button again. And honestly, because I don't go online anymore, I'm a dinosaur now. I go online and it's just, stuff's so... it advances so fast nowadays. Trying to figure out what I need to do. Yeah, I'm probably going to need to get with somebody to help me with setting up a website. Like I say, it just needs to be simple, really simple. The most advanced thing I need to do is a chat room and have where people can make up an account, a username and ID, whatnot, to log into an account. But they can take the test that I'm going to make up. And then if they pass that test, then they can move on to the next section. Like I say, it's just going to be a useful guide to see, just like going to school. You take tests to test your performance, to see if you need any remedial training. Do you need to go back over and study something again? So it's coming, people. I'm working on it. It's just between trying to work on radios and whatnot. Yeah, like I say, I'm going to end up cutting my workload in half. So my income's going to get cut in half for possibly a year or two doing this endeavor. It's already been cut in half because I've been spending a lot of time on trying to do that. Yep, so anyhow, some equipment. I made some equipment changes actually here on the bench. I had a Trimble style GPS disciplined oscillator here at the bench. And that was actually used to be shoved back behind all this stuff attached to the wall. I now have a HP GPS time and frequency reference receiver. So, and then the little box sitting on top of it's a distribution amplifier. I've had that little guy. Actually, I've got two of those here. There's another one shoved back behind down there. But yeah, and I've got big snake cables with. There's a lot of the unused BNC cables, but I forget where I ever got those things, but they're BNC snake cables. But yeah, so the outputs of those things go to stuff like my frequency counter, communications test set. The other signal generator over here, which I use, I'm actually using that signal generator more for frequency counter than I am the actual frequency counter. I just like the display on that. It's really big. The resolution on that thing is amazing. If you go down, if you really slow your gate time down, like if you really want to take precision measurements, which honestly in communications you never do, because you don't need to get really down past the decimal point. 1 hertz resolution is fantastic. If you can get something calibrated to within 1 hertz in a radio, you're doing something. But yeah, that thing will go down, 4 or 5 decimal points, decimal places. So, but yeah, I just like the interface on that. It's really nice. And then, like I say, it goes to all the other equipment. But that way, everything's running off of a high accuracy. It does, so none of this equipment uses its internal oscillator anymore. Its reference oscillator. Everything runs off of that. So that what that does is that puts out a 10 megahertz oscillator, or a 10 megahertz signal, sine wave. Actually, it has an internal oscillator, and then that, because you see it's GPS, it's referenced to the GPS satellites. So the accuracy of the frequency coming out of that is 1 times 10 to the 12th in accuracy. So it gets very accurate signal coming out of that. But like I say, the main reason there is that way when you use something like that, every piece of equipment you have, if that says it's 10 megahertz, if you put a 27 megahertz signal out of this communications test set, hook it up to that and measure it with the frequency counter, you're going to see 27 megahertz. If you turn on the spectrum analyzer, you're going to see 27 megahertz. Everything is referenced to an extreme, and that's one of the biggest things is the signal coming out of that is magnitudes of order more accurate than the oscillators in any of these things. I mean, even this has a ovenized oscillator at a very high dollar precision oscillator inside that communications test set, but that's still more accurate because it's referenced to the GPS satellites. So that's one change I've made here at the bench. Took another meter off there. Actually, I got some other stuff might be going in there. That's another thing you'll find if you start doing electronics. Your bench changes on a almost monthly basis. If you do it full time, you're always finding new stuff. Unless you're rich and you can just go out and buy all brand new stuff, which I can never do. Occasionally I can scrape together enough money to buy some new test equipment. Not the best on the planet, but it's good equipment. But yeah, you're always trying to upgrade and buy better. I can't say it'll be new to you. That isn't new. It's new to me. It's old, actually. That came out of an AT&T cell site. That's what those are used for, mainly around the world. Those are the reference oscillator used at cell tower sites. But another thing is over here to the left, because it will not fit on this bench. If I set it on top of that communications test set, it sticks out to like here. The damn thing's like 24 inches deep. It's just, you need binoculars to see the back end of this thing. And what it is, try and get this turned around without blowing the camera out of the mount again, is an IFR 1900 CSA. So this is another communications test set, more modern than the Stabilock. I still prefer my Stabilock just because of how easy it is to use. I'm trying to get this mount so get it locked in here so it doesn't move around really. There we go. I think that ought to work. But this does some things that the Stabilock doesn't. Luckily, this one it's an all options. There's no open holes in the back. It has everything. Even has the video output on it where I can just hook up a flat screen TV to the back of this thing. But yeah, it does for like when I'm working on amateur radios, DCS, DTMF codes. This will do it flat out. So if I need to check if a receiver is working properly, if you have an amateur radio you use with a repeater network, it uses codes. to integrate with that repeater network. This can do all of the tones for that. It's already, it's part of it, how it works. Honestly, 60-70% of the options that this has, I'll never use. Because they're cell phone based, and I don't work on cell phones. Yeah, this thing has all kinds of options. It do constellation patterns. It's actually some of the amateur bands. The constellation display is kind of nice, but it just does all kinds of fancy things. Right now, I just have it running off a little whip antenna. It has a couple inputs here. It has the normal antenna input for low level signals, and then it has the normal TR input down here. It's a T connector. I just have an N connector, and I have an N to DNC adapter on it. But I just have a little whip antenna on the antenna jack there. The other nice thing about this, that stable lock unit over there doesn't have an easy way, because I deal with two-way radios. It's not like I'm mainly working on just receivers or just transmitters. I'm working on transceivers. So a lot of times I want to put not just a tone. You know, any communications test set can easily put, 1 kilohertz tone or a double tone. When you put it in your RF generator, you modulate the signal. They all do that. And most all of them are going to also have external modulation inputs. Okay, so you can input modulation into them. But the IFRs, not so much just this model, but all the IFRs, they were designed, one of their design features was they're really designed for use with two-way radios. So they have a mic jack. So, yeah. So unlike the other one over there, I have to go in through an interface box to hook up a microphone to go into the, because it's got an external modulation jack. This one's just a lot easier. I just plug the microphone in. I select microphone for modulation, and that's it. Just a push of a button, and it switches over to the microphone. If I want to go to 1000 hertz tone, and this has two tone generators, so it has two separate tone generators, so I can do single or double tone modulation with this as well. But yeah, the microphone, that's another nice addition. Right now I actually have it, FM. So yeah, I actually have this set, let's see, on volume. We're receiving FM radio, and if we change the frequency here, get off of that onto some static. So actually what I have it set up to right now is the spectrum display. So that's actually the spectrum analyzer display right there. But you can see as we tune across the band, and we have our deviation meter here, signal strength meter. It's got your frequency error. The audio, of course, this is a voice modulated or song. It's not like it's a tone, but it's nice. You can see how wide the it's running around. They're running around 80 kilohertz of deviation on that channel. Of course, it's FM in the FM band. There's a classical channel, but yeah. So and let's see. I'll go back to volume. Just turn that back down so I don't get red flagged by YouTube for playing over 20 seconds of any single audio clip. But yeah, I can do with the display. You can do, like, right now it's set to quarter analyzer, so only a quarter of the screen is the analyzer. You can set it to full analyzer. You can set it to quarter scope, so that's actually the oscilloscope pattern right there. So the demodulated audio right there is being displayed. You can go to the full scope, same thing, just full screen, and I've got it set to auto. It should auto scale here in a second. Or maybe I don't. Yep, okay, yeah, there it went. Yeah, to do decode, which I don't need to worry about decode, but has all kinds of media. Of course, it's got all of your meter functions, audio frequency meter, your frequency error, power meter, so watt meter, deviation meter, modulation, distortion, synad meter, signal strength meter, bit error rate, It's got a digital multimeter. I've never used them. That one over there has a multimeter in it. I've never used it. I've got real dedicated meters for that. But something this has that the other one doesn't have is a phase meter. This does phase, audio frequency level meters. It's just screens and screens and screens of stuff. And you go into the, right there I've just hit RF generator, so I can actually pick 3 different modulation sources here, or external. So there's 3 internal modulation sources. There's the external from the external jack, or as you can see, the microphone. And that's the big reason I really like this over the other one. It's just so simple. Just hit mic and grab the mic, and now I can talk into the microphone on this, put the signal out of this into a receiving radio, and see what I actually sound like coming out of that radio. It's not just a tone. A lot of times a tone is deceiving when you're doing troubleshooting, because it's at a set level and it doesn't change. It's exactly 1 kilohertz at 30% modulation, and it's that all the time. It never changes. Where when you start talking into a microphone, when when the radio's receiving a modulated signal, a lot of times you might have a fault. When it's hitting different frequency peaks or something, it might start to become distorted. So that's why it's really handy to be able to do voice modulation out of your signal generator into a radio. Sometimes that really helps with troubleshooting and whatnot. But the receiver, we were listening to that, does duplex, so you can set the receive and the transmit frequencies, which I can do with that one over there. This one just has a lot more features though. So if you're working on duplex, which we're working with repeaters and whatnot, so you can set your receive and your transmit frequencies different. The audio frequency generators. You can go to the scope or the analyzer. Like I said, I already went through the meters, and honestly, I need to sit down and just do some reading, because the manuals, not the service manual, just the operation manual, I printed it all out. It's a stack about that thick. It's thick, man. It's fairly straightforward to use for most stuff. I really need to play with it, and it's just going to be one of those, it takes time when you get something that, multimeter is simple. You turn it on, select AC volts, grab some meter leads, and you can measure. Something like this, the problem with equipment like this is its menu. There's what they call the soft keys down here. So, there's just all kinds of features. You can go in and change parameters and whatnot, and yeah, trying to learn that. But, used communications test sets before, so it was fairly simple to just basically turn it on, and bam, there it was. But, and this also, of course, is running off of the 10 megahertz reference oscillator over there. This actually lets you know on the screen here, there's a little blue asterisk in between the Z and the M of modulation. That means that you're using the internal oscillator is not being used in this. It's being referenced off of your external oscillator. Kind of like my spectrum analyzer here. It actually does. I think it does something the same. It says like external ref or something. Let it boot up. A lot of times digital equipment like this, something that has an actual display will tell you what, right there, external ref says in red. But, because actually I was not running this off of a reference oscillator before. Because actually, honestly, what I'm using that for, I don't really need that to be precise on frequency, but occasionally I'd run into times where I wish that was run off of a reference oscillator, so I knew it was dead nuts on. And I had to pull all this equipment out to get my other reference oscillator out to install this one on the bench. And the other thing I like about this one is if it loses GPS. It's one of the main reasons I wanted this one on the bench here. If there's a torrential downpour or something, so or snow, heavy snowstorms in the wintertime, because it does snow a lot here in the winter times occasionally. I might lose GPS signal. This one has they call it smart switch or something. It's got a processor in there, but what it does is once this has been turned on and warmed up for 24 hours, because this is the one piece of equipment on this bench that will never get turned off. Matter of fact, if I reach down here and only turn this off, and I turn off the power supply, When I turn that switch off there, I just killed, and actually that LED light, if you continue to watch it, it'll get dimmer and dimmer because the capacitors are discharging in it. But I just killed, so you notice the soft key buttons on all of the test equipment around here, they're no longer illuminated or blinking. That's because I've killed the power to everything on this bench, except for that. Matter of fact, you can see the light on the amplifier up there, the little LED light right there, it went out as well. But yeah, so that stays on just like my other one did. That stays on 24 hours a day. But, like I say, the added feature with this one is, if it loses GPS lock, this little yellow light will come on. The GPS light will go out, and the holdover light will come on. So it has an oscillator in there. It's oscillating at, ideally, at 10 megahertz. But no oscillator is 100% perfect. That's why we use the GPS satellite system to reference it to that. That's a globalized time standard. But it will store that difference. It knows what the oscillator inside of this, once it's warmed up for 24 hours and it's been on GPS lock, it's been sampling that over that time frame, and it knows what the difference is between the actual coming from the GPS satellites and what the actual reference oscillator difference is, what that frequency difference is. So if it loses GPS lock, it switches over to holdover, and it uses the internal oscillator, of course, then as the reference because it's a lost GPS lock, but it knows what to offset it at. So it's still very precise. It knows if there was any drift in the internal oscillator in this, that this is what it normally runs at, and it'll run in holdover. So you don't just lose your oscillator in the middle of like I say, in the middle of a snowstorm. You don't have to worry about, oh crap, I lost GPS satellites, a link to the GPS network. It automatically switches over. But there you go. There's just a few updates. Like I say, course. I know a few people have asked when's the course going to start. I'm working on it, people. It's just, it's a lot to. It's a big endeavor for me. Like I say, trying to start this from scratch. I think there were one or two people that had volunteered. I need to go back to the other two videos I did on kind of describing the electronics course. I need to go back through and see, maybe I can get a hold of one or two of those guys and see if we can work on, somebody could work on setting up. If I have to pay for a website, I'm going to have to pay for a website. I mean, like I say, the course is costing me money just because I ain't making no money when I'm working on course material. If I got to pay somebody to help me design a website or something, I guess I'll have to. But I've got to make it user friendly. I don't want a fancy, complicated, just pages and pages deep of stuff. It just needs to be a simple page where document downloads. People can download documents. Either a schematic or a parts list or something, a forum if they need to chat with other people that are taking the course. They have questions and whatnot, and somewhere where they can take tests. And then maybe I'll put, like I say, a links page for useful web pages where you can get other good information on electronics. I can put recommended equipment and whatnot. Like I say, I'm really thinking that Red Pate is going to be the bee's knees, as they say. I just don't see anything else out there that will allow someone to get so much functionality for a limited price like that. It's going to be expensive. I mean, honestly, if you're on a shoestring budget to start with, yes, that's going to be too expensive for you. But if you think about it, what you would pay for a used signal generator, for a used oscilloscope, by making sure, because a lot of times that stuff doesn't come with probes or cables, so you're going to have to buy those separately. Like I say, this comes with the advantage of being a spectrum analyzer, and if you want the more fancier options, you'll be able to buy those options, or you can just get the ultimate kit to start with. But yeah, I honestly think that'd probably be the way to go. And if I buy one and use that in the course, and most of you that take that course get one of those, then we're all using the same instrument. That way, when I change a setting on, let's say, an oscilloscope, I'm not going to use my oscilloscope here, because everybody's scope is different. In fact, it's the last thing we need is a couple dozen or hell, hundreds of people asking, well, how do I set that up on my scope? I don't know. I don't own the scope that, I might not own a copy of the scope that you have. It's like people ask me about, well, how do you use a spectrum analyzer? I mean, there's basics of how you use a spectrum analyzer, but honestly, unless I had your spectrum analyzer sitting here in front of me, I don't know how to tell you to use it, because the menu features, which buttons you press, what features it has, I don't know. So if we're all using the same thing, it'll just make it a lot easier for people. There's going to be a lot less confusion. When I say set something to 5 microseconds per division, for time base, and I don't know, half volt per division on the scope, will all be on the same. You can see me set it. Like I say, I'll probably just run that off of a tablet. The screen's just about the right size. Now, there is a little bit of glare I noticed on that tablet screen. I think you can get anti-glare material to put on them, so that's probably what I'll do. I'll get like an anti-glare decal, those clear see-through stickers you put over the screens. But that should help a little bit with the camera here, so it's not being blinded by the display of that. You don't get a lot of glare from overhead lights and whatnot. But there you go. There's just a quick update. Like I say, I wanted to. I'm working on the course. It's coming. Only a few more weeks, hopefully, and I should have videos should start being published. Now, don't worry about getting any of the advanced equipment to start with. When we first start this course, it's mainly going to be a multimeter. Multimeters, what you're going to need is going to be a multimeter, power supply, and I got to get, like I say, a website up so I can upload parts lists. But for the DC portion of the course, you're not going to need a lot of parts for that course. It's mainly going to be just mainly a lot of passive components. Resistors and capacitors, switches, and just stupid little things like that. So, to start the course off, it's not going to be... And a lot of you, if you already tinker with electronics, you probably already have everything you need. You probably already have a multimeter, little project box full of a couple of with resistors and capacitors and whatnot. So... it's coming. I'll keep you updated. Like I say, I'm going to get one of those red patillas, and I'll probably do a separate review video on that before I actually start the course. And I'll show it. Once I get one in front of me and actually use it, then I'll know if I think it's worthwhile using that as my recommended piece of test equipment for the course. I really need to get my hands on one and actually touchy-feely. Actually do some testing with it, and measurements and whatnot, and see if it'll fit the bill. And if it does, like I say, then I'll recommend it. But that way, you'll also get to see how it works, and before. So there you go. There's just a few updates. And oh, by the way, I've added links in the description. I usually don't ever put anything in the description blocks. If you've ever watched any of my videos, normally when you go to the text, if you click on description, there's nothing there. Because, the title usually says it all with my videos. It's a repair or a review of a radio or something. I have added links down there. If you want to make a donation, to help with the course, like I say, buying stuff to get me with the course and help to pay for the website and whatnot, I've added links for PayPal and Patreon. I really didn't want to do Patreon. I got a few people have already hooked up on that. I really didn't want to do Patreon. PayPal is just easier. The Patreon thing, that's a monthly thing. I don't know, whatever. But if you want to make a donation, you now have two ways of donating. You can click the PayPal, the PayPal Me link, or the Patreon link. So, anything helps. Like I say, that'll help to offset a lot of the revenue that I'm losing by not being able to work on radios, because I'm working on that course. So, and we'll see you soon.